So in this video, we'll discuss the formula for the general term of an arithmetic progression. We'll do that with the help of an example. So let's consider this series, or this arithmetic progression rather, 5, 8, 11, 14, 17, 20, and so on. Let's name all the terms. So the first term we'll take it as T1, second as term 2, third as term 3, term 4, term 5, term 6, and so on. If you guys remember in the previous video, as when we were discussing the variables, the parameters of an arithmetic progression rather, we denoted, like we discussed that the first term T1 is, we also use a variable a for that. So in this case, the first term, the T1 rather, is 5, right? Now, the common difference is nothing but the difference between any two successive terms of a arithmetic progression, any two consecutive terms, so T2 minus T1 or T3 minus T2. So 8 minus 5 will give me 3, 11 minus 8 will also give me 3, 14 minus 11 will also give me 3, so as expected. Well, the common difference here is going to be 3. Alright. Now, I wanted to bring something to your notice here. If you guys see, the first term we know is T1, which we can also denote with the value with a variable a, right? Now to this term, first term, if I add the common difference, right, I get the second term. So the second term is just the first term plus the common difference, right? Now the third term, to get the third term, again I just need to add the common difference. So a plus d is nothing but a plus 2d, right? And again, I just have to do the same thing. I just need to add the common difference. So a plus 2d plus d will give me the fourth term, which is a plus 3d. The fifth term will be a plus 4d. The sixth term will be a plus 5d, right? Okay. So just make a note of one thing over here. So if it is a sixth term, it is a plus 5d. If it is a fifth term, it is a plus 4d. If it is a fourth, it is a plus 3d. If it is a third, it is a plus 2d. If you didn't notice that yet, what I'm trying to tell you guys. So if it is the second term, it is a plus 1d, and if it is the first, it is a plus 0 into d, basically, right? And what I would have liked you guys to have noticed on your own would have been that, so if it is the fifth term that I'm talking about, if it is the sixth term that I'm talking about, it's basically, I can write this a plus 5d as a plus 6 minus 1 into d. The thought is to relate this 6 over here and get that value within the formula as well, right? So if it is if it is a fifth term, it's a plus 4d, and a plus 4d can be written as a plus 5 minus 1 into d, right? The third term, yeah, let's jump to the third term here. It is a plus 2d, right? So if it's the third term is a plus 2d, and 2d can be written as, so it can be written as a plus 3 minus 1 into d. So if it's the third term, it is 3 minus 1 into d, right? And by extending the same logic, actually, we can figure out what is the general term, the formula for the general term, right? So the general term is basically just any term, the nth term or the mth term, right, of a arithmetic progression, and that can be written with the formula a plus n minus 1, right, n minus 1 into d, right? So if you can see, as you can see over here, the sixth term was a plus 6 minus 1 into d, a plus 5d. The fourth term, right, is a plus 4 minus 1 into d. So the nth term, the general term, is a plus n minus 1 into d. This is the formula that we're going to use in this chapter, right? And now we know the first term is 5. We know the common difference is 3. Suppose if I wanted to find the 52nd term for any reason in this question, so I can say T52 is equal to 5 plus 52 minus 1 into 3. Now if I solve this equation, or if I solve this value, if I numerically solve this, I can get the 52nd term of this particular arithmetic progression, and all with the help of this formula for the general term. Tn is equal to a plus n minus 1 into d.